So write the polynomial equation, a possible one. Now, there's the a value in a polynomial equation is one that you're not probably going to be able to figure out here. They don't need an a value. They say one possible. So it doesn't have to be the exact one. Okay, so an equation using all the parts of this graph that we have learned about. That is the end behavior, the zeros, and the zero behavior. You can build an equation, one possible equation for this. Oh, also the Y-intercept should line up as well. But the particular a value, I don't think you're responsible for in this question. So what do we know about this? Can you guys see that okay? First of all, I know that, look at the end behavior. So that's going to be an odd function. It's going to be of odd degree. It's not linear, obviously, so it's going to be 3 or 5 or 7 degree. So that means we're probably going to have, and it looks like we do have, 1, 2, 3 intercepts. So it's going to be odd degree. There are 3 intercepts. And we can start identifying those here. And I can see clearly the behavior at each intercept is just a cross. So it's crossing at each intercept. If I zoom in there, it's not tangent to and crossing. It's not tangent to and not crossing. It's a straight cross here. It's a straight cross and a straight cross. So that means the multiplicities on each of these roots are going to be what? 1. Very good. That's right. So multiplicity of 1 on each root. Okay. So what are the roots? Well, the roots of this are -3 and -2 and +1. So I can take those roots of the graph and I can translate those into zeros of the function, right? I can write 3 factors here of this polynomial. It's going to look, what's the first one going to look like? X plus 3. Very good. That's this root translated into a binomial factor. You change the sign, right? X plus 3. Easy. The next one would be x plus 2. Good. And x minus 1 here. Yeah, so we change the sign to -1. Okay, awesome. That's a great start. Let's check a couple things. Let's check a couple things to see if we're on the right track. Would this be degree 3? Now, we got x to the 1 times x to the 1 times x to the 1. That's x cubed. If we were to expand this out, the first term is 1x cubed. It's a degree 3. We didn't write up here, but it's got a positive leading coefficient. How do I know that? Because it starts down here and ends up here. If it was a negative leading coefficient, it would start up here and end down here, right? It would go the other way. But it's positive, so that all works out real good. And my y-intercept is -6. So let's see, 3 to the 1 times 2 to the 1 times -1 to the 1. What is that? 3 times 2 times -1 is -6. That indeed is my y-intercept. So this all lines up for 3a. Here's your answer right here. That is that's a possible equation for this graph. Okay, again, I said you don't have to identify the a value. The a could be 1. The a could be something different. But it looks like because this, lines up just from these numbers, multiplying them, it looks like the a would be 1. All right? Okay. Any questions about 3a? So that's an example of getting an equation from a graph. Now this one here, number 7, is sort of this is putting a lot of stuff together here, right? We have to factor, we have to look at the intercepts, the multiplicities, the end behavior, put it all together to sketch. So this is the culmination really of what we're learning in this section. So let me just make some space here for us. All right, so find the x-intercepts, find the degree and the end behavior. Awesome. Zeros and multiplicities, y-intercept, and then, the intervals where the function is positive and negative. We haven't focused a lot on that yet, but let's go over this question. Okay, so to factor this, notice that there's an x as a common factor in all of the terms. So the first thing you're going to want to do is take the x out, and you're left with x squared minus 4x minus 45. You see that? So really, this x by itself is the same as an x minus 0 as a factor. You see that? So you don't have to write that. You just understand that we're going to have a 0, like x equals 0 as an x-intercept. And then can we factor this just by sight without using synthetic division or anything like that? Maybe. What are the factors of 45? 5 and 9 come to mind, and that difference of negative 4, that looks like it could be possible. So if we factor this by sight, this is going to be an x and an x here. So we're going to have negative 9 looks like, and a positive 5. Are you guys okay with that? Negative 9 times positive 5 gives us negative 45, and negative 9 plus positive 5 adds to negative 4. So here is our equation that's all factored. We didn't have to do any synthetic division. All right, so from this, x-intercepts. Okay, x-intercepts. This is for, whoops, I guess not A, it's letter 1. So x-intercepts are going to be what? X equals 0. Don't forget the 0 from this one. Positive 9 and negative 5. Number 2, the degree and end behavior of the graph. So the degree is going to be what? Well, we know the degree here from the standard version there. It's 3. So degree 3. End behavior. What is the leading coefficient? It's a positive value. So the end behavior is going to be what? 3 to 1. 3 to 1. So if we're doing a little sketch here on the side, which I just realized that if I'm recording this, probably can't see all that behind my fat face there. So I'll bring that down a bit. So if we're sketching this, 0, 9, and negative 5 are the x-intercepts. So there's one there. There's over here at 9 and negative 5 over here. And we're starting in 3 and ending in 1. Okay, so it doesn't say to graph, I guess, but to sketch it, this is what it's going to look like. All right, what else? Zeros and their multiplicity. Okay, well, we know the zeros are negative 5, 0, and 9. That's the same as the x-intercepts. So the zeros, x equals 0, 9, negative 5, same as the roots. And the multiplicity, okay, on each one is 1, right? 1 on each factor. There's a 1 there, there's a 1 there, and there's a 1 there.
Because it's not tangent with this one.
That's right. So because these are 1, that means that these intercepts, the graph is just going to straight cross at those spots. That's right.
They were 2.
So yeah, if 1 was a 2, well, if 1 was a 2, this wouldn't be degree 3 anymore, things would change. But if one of these was a 2, that means the degree would change, so the end behavior would change. And whichever one had the 2, like let's say it was this one, then this would just be like this. It would be like that if it was 2. Then it would cross, then it would cross. That's what it would look like.
Travels a bit longer yet.
Yeah, and 3, yeah, that's right. Yeah, 3 is tangent to and crosses though. So let's not get too far ahead of ourselves. But this is just yeah, like that. What's next? Y-intercept. Oh, Y-intercept. Okay, so the Y-intercept would be the constant in this standard term, right? Or it would be the multiplication of all the constants in each factor. So remember that this x has a factor of 0. So 0 times negative 9 times 5 is 0. There's no constant here, so that's understood to be 0 up there. So for number 4, Y-intercept is y equals 0. Now, the intervals where the function is positive and where it's negative. Okay, we haven't focused on that, but I'm actually gonna sketch this graph for you now that we know everything that we know. So it's gonna start down here somewhere. It's gonna cross at negative 5. It's gonna cross at 0, and it's going to cross at 9. So that's kind of what it looks like. And from here now, you can see where it's positive and where it's negative really easy. Okay, so for this one, 5. So let's say that y is greater than 0. Okay, where is that? Between negative 5 and 0. So do you guys know this notation? Negative 5 just comma 0 with the square brackets like that, or the round brackets. That's interval notation. Have we done interval notation? Yeah. Yes, no? I think I talked to you about it, yeah. So from negative 5 to 0, as well as, I don't know if you've seen the union before, as well as 9 to infinity. Interval notation? Yes, no? Sort of, okay. Also, you could say this right here. So it's greater than 0, where x is between negative 5 and inclusive and to 0, as well as x greater than or equal to 9. That's another way to write that. So this is interval notation up here. This is set notation. Okay, or positive in these. So that's here and here, right? That's where the graph is positive. Negative would be, so negative, if I do the interval notation, x less than -5. And actually, if it's just positive, I don't know if we'd include 0, guys, technically. So, anyways. I'll just do set notation to make it easier for you. X is less than -5. This is where it's negative. And then between 0 and 9. 0 less than x less than 9. So I don't think I've done an example like that with you for a while, but that's where it's positive and negative. And it's easiest to maybe sketch the graph first to see that. You don't have to sketch the graph first. You can work it out in your mind. Okay, if it starts, quadrant 3, and then it comes up to the first intercept, that's where it's negative. From negative infinity to the first intercept, whatever. But graphing it, I think, is pretty easy to do. Okay, any questions about this one? Okay, so that's number 3 and number 7 for you.